Lesson 6-5, conditions for rhombuses, rectangles, and squares. So in this lesson, we're going to be able to determine whether a parallelogram is a rhombus, a rectangle, and or a square. We're going to learn 3 theorems to help us do this. The first one is parallelogram perpendicular theorem. It states, if the diagonals of a parallelogram are perpendicular, so if they're perpendicular, we know it would form 90 degrees right here, then the parallelogram would be a rhombus. So if this polygon ABCD is in fact a parallelogram, and this symbol says parallelogram, and if segment AC is perpendicular to segment BD, then we know that parallelogram ABCD is in fact a rhombus. And that is our first theorem. So if the diagonals are perpendicular, then it is a rhombus. Second one, if the diagonals of a parallelogram bisects a pair of opposite angles, then it's a rhombus. So if it bisects opposite angles, let's label our angles right here. And I will name this angle 1, angle 2, angle 3, and angle 4. So what this says, if this shape ABCD is in fact a parallelogram, and angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, then parallelogram ABCD is in fact a rhombus. Our second theorem to find out if it's a rhombus. And our third theorem, parallelogram congruent diagonals theorem. If the diagonals of a parallelogram are congruent, then the parallelogram's a rectangle. So if ABCD is in fact a parallelogram, and AC, segment AC, is congruent to segment BD, then we know that parallelogram ABCD is a rectangle. And we also know a rectangle would have the right angles. So we can conclude that a parallelogram is a rectangle if the diagonals are congruent, and we can conclude that that's a rhombus if the diagonals bisects the opposite angles, or if the diagonals are shown to be perpendicular in the first 2 theorems. So let's try and practice these theorems. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Well, in this first picture, we can see that the diagonals bisects 2 angles. So by the angle bisector theorem that we just have learned, we know that this has to be a rhombus. In the second picture, we can see that the diagonals are congruent. So by the parallelogram congruent diagonal theorem, this parallelogram has to be a rectangle. But we also see that the diagonals are perpendicular because of this 90 degree. So by the parallelogram perpendicular theorem, we also know that it is a rhombus. So note here, if a parallelogram is both a rectangle and a rhombus, then we can conclude that it is a square. All right, let's practice one more. For what value of x is parallelogram ABCD a rhombus? Well, for it to be a rhombus, we know that the diagonals must bisect opposite angles, which would make this angle bisector. So these angles would be congruent. So we could set this up 6x minus 2 equals 4x plus 8. We would solve this by subtracting 4x to both sides of the equal sign. And we're left with 8 equals 2x minus 2. Add 2 to both sides. We are left with 2x is equal to 10. Divide both sides by 2. X is equal to 5. And we could check our answer by substituting 5 in both equations. So 6 times 5 is 30. 30 minus 2 is 28. Does that equal 4 times 5 is 20. 20 plus 8 is 28. So we can check our answer this way. All right, here we have it, the 3 theorems for this lesson, and now it's your turn to practice.